Okay, so finishing this up on 92C. I think I start all these videos with okay, and really you don't need to. It looks like I'm upset about something, but I'll move that X out of the way. Okay, so it says the functions f and g are differentiable. Nice, they're differentiable, which means you're able to take the derivative and selected values of them, and their first derivatives, f prime and g prime, are shown in the table below. Okay, so we have a table. Use the table of values to answer the questions that follow. So let's do that. This one says, find the value of g inverse of 1, but I'm finding the derivative. So the derivative of g inverse of 1. So remember,
if there's a Devani Hickok in the building, please come to the main office.
if that's you, you should go to the main office, but I don't know that person, so you can't go to the main office. Okay, so what I'm going to do is, just so I don't have to flip back and forth from the old page, I'm going to go back here, and I can see this. I'm just going to write on the top of the page so I can reference it. F inverse of x. Okay, so in this first one, it's saying find this value. I just dropped a bunch of stuff, so I'm going to pick those up. And so what I'm going to do is I'm finding this value for the derivative. So I'm going to write g inverse 1, but I'm finding that derivative. And I would get 1 over g prime g inverse of 1. So I'm using this, 1 over g prime, g inverse of 1. I'm working inside out, so g prime, g inverse of 1. See, there's no g inverse. So what I'm going to do is I'm going to look for my y value of 1, and I can see that's my x value of 3. G prime of 3. G prime of 3 is going to be negative 2. And so think about this for a second. I found this value, so that's good. I've got negative 1/2. But then it says you need to find the equation. And whenever you're finding the equation, you need two things. You need a slope and you need a point. This is my slope. With my point, you have to be careful about this. So I know this says find the equation of the line tangent to the graph of g inverse. So if I go, I can find my point pretty easily when x is 1. So it says g of 1, go up here, g of 1 is negative 2. G inverse is not going to be the same though. Did I do that right? 1 second. G, where's G? I don't know why I picked this one. It says when x is 1. There we go. Oh, I see why. Okay, so up in this graph, I've got g of 1, and I've got negative 2. But that's not going to help me in this graph, because this is talking about g inverse. So I no longer can think about that one. I need to be thinking about, well, where is g of something going to be equal to 1? Because my x and my y switch. So if g inverse, g of something, oh look, g of negative 2 is equal to 1. So everyone see that? So this is saying g of negative 2, g of hold on a second, I did it wrong again. There it is. Oh, guys, one more time. This, you have to be super careful when I'm reading this. It's like we're doing this in class because I'm not going to tape over this again. Okay, so g of, there's 1. I'm circling it so I can see. G, this is my x value of 1 and 3. Do you see where that's coming from? We can do this. I'm writing a marker. Okay, g of 3 is 1. Everybody with me now? Okay, g inverse then of 1 would be 3 because my x's and my y switched. So when you're writing this, this is my slope, this is my point. Y minus y1 is equal to m times x minus x1. Ta-da! We did it! And you could simplify, but I'm not going to. It says estimate the value of g prime of negative 1. Based on this value, what conclusion can be reached about the graph of g when x equals negative 1? Okay, so I'm estimating g prime of negative 1. So this isn't anything crazy. This isn't asking about inverses. It's just saying g prime of negative 1. If I go up here, g prime, oh look, negative 1's not on here. Anytime you're asked to estimate the derivative, don't take these two values, add them up, divide by 2, or do something crazy. G prime of negative 1 is the slope of the tangent. The way to estimate it is by doing a different slope, the slope of the secant. So it's going to be approximately picking two values on the graph of g. So I'm going to say g of negative 2 minus g of 0, or negative 2 minus 0. G of negative 2 is 2. G of 0 is negative 3 over negative 2. Got 5 over negative 2. And then it says, what conclusion can be reached about the graph of g when x equals negative 1? Well, this is g prime of negative 1, and I know that this is estimating the slope of the tangent, and I see that it's a negative. Therefore, I can say g of x is decreasing at x equals negative 1 as g prime of negative 1 is less than 0. Whew, double derivative. This says estimate the value of g double prime of negative 1. So if you think about this, this is the slope of the slope. And we have g prime right here. So I'm going to do, so I've got g prime. So g prime of negative 1. So I'm going to look at the graph of g prime and find the slope, because that will give me the slope of the slope. So the same thing I did up here, but I'm going to do it with the graph of g prime now. G double prime of negative 1 is going to equal g prime of negative 2 minus g prime of 0 over negative 2 minus 0. And so this is saying g prime of negative 2 is 3 minus g prime of 0 is 2. So I'd have negative 1/2. And it says what conclusion can be reached about the graph of g. And what this is I can say g of x is concave down. Anytime we find something out of about the second derivative, it's always talking about concavity of whatever the original function is given. So g of x is concave down, and my reason would be, well, I could say at x equals negative 1, as g double prime of negative 1 is less than 0. So g of x is going to be concave down, something like this. Increasing, decreasing, I don't know. Actually, I do, because I can see it's decreasing. So it's going to be somewhere like on this side of a curve, but it's definitely going to be concave down.